Good morning everyone. Last time we have discussed about the empirical formula, molecular formula and its calculation with the help of the table. I think you have understood it. Now this time we are going to study about the stoichiometric calculation. That means the calculation based on the chemical reaction, balanced chemical reaction, the amount of reactant and product ratio. And in this one we are going to study about the limiting reagent. Then first of all, what is the stoichiometric calculation? The calculation which is based on any balanced chemical reaction, that is called the stoichiometric calculation, or the calculation which is based on the ratio of the reactant and product, that is called the stoichiometric calculation. Now what are the limiting reagent? When we talk about the limiting systems, then we say that those of the systems which are responsible, which are capable to stop, to limit the process is called the limiting system. Similarly, in any of the chemical reaction, when any of the reagent is responsible to limit the reaction, to stop the reaction, that specific reagent is called limiting reagent. Then what are the limiting reagent and how you will find the limiting reagent? When you will talk about the limiting reagent in any chemical reaction, then we say if there are more than a single compound which are reacting with each other, or more than a single element which is reacting with each other, in that specific condition, if you are considering that C plus O2 gives CO2, in which if 12 gram of carbon reacts with 32 gram of oxygen, it gives carbon dioxide. That means the complete consumption of the carbon and oxygen is taking place. But it is not necessary that every time what amount of carbon and oxygen is needed, the same amount is available. And if same amount is not available, then what happens? There may be only 10 gram of carbon along with 32 gram of oxygen. That means before the consumption of oxygen, the carbon will be consumed. And if the carbon consumes first, then after the consumption of carbon, the reaction will stop, the reaction will limit at that specific value. That means here carbon is responsible to stop the reaction, here carbon is responsible to limit the reaction. Similarly, if you are taking 12 gram of carbon along with 30 gram of oxygen, then you can see that the oxygen will consume first and oxygen will be responsible for limiting the reaction, and this is called the limiting reagent. And if it is limiting reagent, then how it determines the reaction, how it determines the amount of product. So simply we can say that the limiting reagent is the factor which is capable to suggest that what amount of the reaction will take place, or the limiting reagent is the reagent which will suggest that what amount of product is going to be found. So on the basis of limiting reagent, we can find the amount of the product. I am taking one example, and by taking that example, we are trying to find the limiting reagent as well as the amount of product found in presence of limiting reagent. Okay. So here is the question. In this question, carbon is reacting with oxygen to give carbon dioxide. The reaction is already a balanced reaction. According to question, 10 gram of carbon is treated with 30 gram of oxygen to yield carbon dioxide, and you will have to find the limiting reagent as well as the amount of carbon dioxide found. And I have already said that it is the limiting reagent which will determine that what amount of product is going to be found, because limiting reagent is responsible to stop the reaction. For example, अगर हम एक क्रिकेट मैच का एग्जाम्पल लें, if two teams are playing together and at the time of night one team says that I am not able to see the ball properly. Normally ऐसा होता है बच्चों में, दो टीम खेल रही होती है तो बैटिंग करने वाले तो हमेशा तैयार रहते हैं, बॉलिंग करने वाले तैयार नहीं रहते. इवनिंग टाइम में बॉलिंग वाले नॉर्मली कह देते हैं बॉल नहीं दिखाई दे रही, हम नहीं खेलेंगे. In that condition, what happens? The team which says that we will not play, we are not able to see the ball, that is responsible to stop the game, and that is the limiting agent there. And that team will determine that how much play will proceed. If they are saying after 2 overs that we are not able to see, the game will be only 2 overs. If they will say that we are not able to see after 10 overs, that means the game will proceed for the 10 overs. Similarly, the limiting reagent in any chemical reaction, it's the limiting reagent which is responsible to determine that what amount of reaction will proceed. And so, first we are going to find the limiting reagent. So, we are finding it on the basis of the mass, not on the basis of the number of moles. So, according to reaction, 1 mole of carbon reacts with 1 mole oxygen. That means 12 gram carbon reacts with 32 gram of oxygen. Similarly, 1 gram of carbon will react with 32 by 12 gram of oxygen. That is 3 jar, 8 jar, that is 8 by 3. Similarly, 10 gram of carbon will react with, here 10 gram, available carbon is 10 gram. So, 10 gram of carbon will react with 8 by 3 into 10, that is 80 by 3. On solving, it will be 3 to the 6, 6 approx gram. That means for reaction with 10 gram of carbon, 26.67 gram of oxygen is needed. But what is the amount of the available oxygen? The available oxygen is more than the amount needed. So, oxygen is not going to limit the reaction. And if oxygen is not going to limit the reaction, it will be carbon which will limit the reaction. So, you can say available oxygen is greater than needed oxygen. So, oxygen is limiting reagent. And if oxygen is limiting reagent, then we will calculate the amount of carbon dioxide on the basis of the oxygen. You can take the screenshot of this calculation. So, here we have found the limiting reagent, and the limiting reagent is carbon. And if the limiting reagent is carbon, then on the basis of the amount of carbon, we will find the amount of carbon dioxide on the basis of the stoichiometric calculation. So, according to reaction, 1 mole of carbon gives 1 mole of carbon dioxide. And if 1 mole of carbon gives 1 mole of carbon dioxide, then on that ratio, we can find the amount of carbon dioxide. So, 1 mole carbon is 1 mole carbon dioxide. That means 12 gram of carbon is 44 gram, that is the molecular mass of carbon dioxide, 44 gram of carbon dioxide. So, 1 gram of carbon, the calculations are very simple in chemistry. You just have to use those of the formulas which you have studied in the lower standard. So, 1 gram of carbon will yield 44 by 12 gram of carbon dioxide. And what is the amount of carbon? That is the 10 gram. So 10 gram of carbon will add 44 into 10 by 12 gram carbon dioxide. That is 4 3 ja 12, 4 11 ja 44, 11 into 10 by 3, that is 110 by 3. By solving it, 3 3 ja 9, 2 36.67 gram, and this is the amount of carbon dioxide. Just note it. So this was the limiting reagent, and this is the way how to calculate the limiting reagent. There are few examples in your NCERT book. You can solve and see that how the calculation is taking place. The sum of the questions what you can solve is example 1.5, where you have to find the amount of ammonia during reaction of nitrogen and hydrogen if 10 kg of hydrogen reacts with 50 kg of hydrogen. The second one is question number 1.23 from exercise. There also you will have to get the limiting reagent. One more thing, I have calculated on the basis of the mass. We have directly taken in term of the mass. Initially I have taken 1 mole of carbon reacting with 1 mole of oxygen, and according to that we have converted it in the term of the gram. But another way which generally many of the people use or many of the teachers suggest, that is we just go through the number of moles, no any mass calculation takes place during the reaction, during the calculation. Only after the calculation we find the mass. So in that process, if you will have to proceed in the same way, we first find the number of moles. That means according to reaction, 10 gram of carbon means 10 by 12 mole of carbon, 30 by 32 moles of oxygen, and on the basis of these of the value, we have taken the 10 gram of carbon and 30 gram of oxygen. Instead of taking 10 gram of carbon, you will take 10 by 12 moles of carbon and 30 by 32 moles of oxygen, and on that basis you can calculate the number of moles of carbon dioxide produced. The answer will be same, only you will calculate on the basis of number of moles, and I have calculated on the basis of the amount of mass. In the next class we will discuss one of the questions on the basis of the number of moles, and then we will see the mole concept along with the molarity and mole fraction and other terms, which are very important for this year as well as for the next year. Till then, thank you. Have a nice day.